Hello everyone, this is Puya. This short lecture is about Deques or double-ended queues. So a deck is a double-ended queue that allows items to be inserted and removed from either end. So we already discussed what a stack is, what a queue is. You remember that stacks are abstract data types. It's a container of data that you can only have access to the data to insert and remove data from one end, which we call top. And queue was another abstract data type that we had access to data from two ends, but you could only insert the data from one end, which we call back or rear, and you could remove data from the front, which is uh, the other end, right? So like two ends, one end for insertion, one end for removal of the data. But Deque is basically a generalized version of queue that you can insert or remove from either ends. It's like a deck of cards that you can remove or insert a card from either ends. We can implement Deques using circular arrays or using linked list. I'm going to show you how to do that later. Um, uh, the, the, the the spelling for double-ended queues is usually done like this so that it's not confused with the DQ operation, and it's pronounced Deque again so that like it's not confused with the DQ operation that we do for queues. So now that we have two ends and we can do insertion and removal from either end, the operation that we can have for a deck can be insert from the front, insert at the front, insert at the back, remove from the front, or remove from the back. Okay, so you can see that now we can use a deck to implement both stacks and queues. If you implement a deck to work as a stack, you would basically be using only insert from front and remove from the front. And if you wanted to, sorry, from the stack is going to be inserting from the front and removing from the front. And if you want to implement it to work as a queue, you would be only using remove from the front and insert at the back. Okay. So assuming that we already have a class deck and you want to implement class of stacks and class of queues, we can do that. We can write a class that implements a stack but only uses a deck objects to do so, right? Because decks can operate as stack or queues. If that's the case, we call the new class that we implement to work as a stack or queue, we call it an adapter or a design pattern. I'll show you through this example. Let's say that we have already implemented the class of deck, and now we want to have a class of stack, right? We can just like re-implement everything from scratch, but that's going to be a waste of time because you already have everything that we need. And so what we can do would basically just use the um, deck operations to do pushing and popping for the stack. The same story can be applied for the queue class. You can implement a class based on a deck object. So this stack class is called the adapter, or also known as a wrapper class, that will use the existing deck class and its objects and its member functions to do the operations that the stack needs to do. Okay, so we basically delegate some of the operations like pushing and popping to member functions of the deck class. So like if you want to push, you can see that here, this is the implementation. We didn't implement it from scratch. We just like use the insert front and remove front to implement push and pop operation for the stack. The same story can be applied for the queues. That case would be insert at the rear and remove from the front for the queue. What are the applications of Deques? So because Deques can be stack or queue, so you can think of all the applications of stacks and queues can be also applied to Deques. But a couple other important characteristics or applications of Deques are it can be used as a palindrome checker. You already know like what a palindrome string is. For example, um, like a palindrome, a string is a string that would be read the same way from either end. So for example, dad doesn't matter if you read it from left to right, or right to left, or mom, or what else can I say? Race car. If you read it from left to right or right to left, it's the same. So we say that this is a palindrome string. So Deques can be used as a palindrome checker. The other important applications of Deques is something called A-still or work stilling algorithm. An application of that is in multiprocessor scheduling. So you would have two different processors. Let's say like you have a dual core processor. Each of them would have a certain task to like they're scheduled to do certain tasks. But one of them finishes their tasks um, earlier than the other one. So what this processor would do would steal like one task from the other processor, from the rear of the other processor, and try to just process that to save time, right? Because it already finished like whatever it had to finish. And the same story can be applied to the other processor. So you can see that in these two processors, pushing and popping data can be applied from both ends. So this is a good example, a good application of Deques. We call it a still algorithm. If you have time, we're going to go through this and see what this is and how we can implement it using Deques. Last thing I wanted to mention is that similar to stacks and queues, C++ standard template library has a Deque class, and it has many member functions like push back, push front, pop back, pop front, which are like the member functions that we mentioned. Another member function that it has, it's called the at member function, which is gonna work similar to the index operator, the square brackets for the arrays or vectors, but it has the advantage that you can take advantage of the exception handling when you use the at instead of index operator. Size and resize, so you can like find the size, the number of elements in a deck, and you can resize your deck. You can clear all the elements. You can find the first data, you can find the last data, you can find the front, you can find the back. And so the begin and end, sorry, these are the pointers to the first data and the last data. And you can find the front and the back, which is the last data and the last data in the deck. Yeah, so I highly encourage you to go check out this link to learn more about the member functions of Deque class. And you can also compare Deques with the vectors. You're already familiar with vectors. You've probably seen this in your previous courses. So you see that in Deques we had in vectors we also had pushback and popback. Um, but Deques also has push front and pop front. So in applications that you need to work from both ends, it's recommended to use Deques. Otherwise, vectors can also do the job if you're only doing operation from one end. That's all I wanted to share today. So I'm gonna show you how to implement Deques a little bit later.